Good evening, everyone. To add something about myself, on top of what Leon well mentioned, is that I have more than 6 plus years of experience in embedded domain, and I've worked on classical AUTOSAR and adaptive AUTOSAR platforms. I've worked with the teams who are responsible for creating the specifications of AUTOSAR consortium, premium partners. I have also worked on different other projects related to vehicles or smart systems like ADAS, HVAC, and whatnot. Currently, I'm working on the AeraCom module, which is again a part of Adaptive AUTOSAR basic software, we can say. So that was all about myself. So today we will be discussing on the future of intelligent mobility with Adaptive AUTOSAR and how it is transforming the what vehicles EE architecture. So first we will see what is the landscape of electronic auto cars and what are the challenges faced by the OEMs. Then we will discuss on AUTOSAR's take on providing solutions for these challenges. And at the end of it, we will have a short Q&A session where we can discuss your queries. So during this session, if you have any queries, please put them in the chat. So let's get started. In this day and age, we can see mobility is the most important aspect of people's life. People want to travel more, and our today's lifestyle requires us to travel more, except from the part of Corona. But now, if we want to do the business or if we want to achieve something, we have to travel. And for travel, the most convenient way is using a car. So those days are gone when cars were just like a gas guzzling mechanical machines. Now they are more like a service or more like some device which is providing you comfort and safety. Something like your laptop or mobile phone. And this is not going to go down. This is only going to go up from here. So cars will keep on adding new features, keep on adding new services, and governments or authorities will keep on imposing restrictions on OEMs to add new safety features because we know, despite all this progress, their cars are not that safe. So there are a lot of accidents and all.
Safety features, we need more comfort and we can say good experience. Okay, so at the core of all this is ECUs. ECUs are electronic control units, and with this what we can see in the future is fully automated electronic cars which will connect with each other, with their environments, maybe with other cars, signals, traffic systems and whatnot, to provide you state of the art functionality. And this E2E environment, when we say, is basically architecture where all these ECUs are connected together to make a consolidated car. Individually, they are providing their own features. They have their own inputs and outputs and whatnot. So these networks are evolved over decades, like 2 to 3 decades. These networks are evolved from distributed systems where each issue is minding their own business and just together they are making one network. There is few data exchange going on. To today's architecture where we can see from the likes of Teslas or BMWs or Mercedes top vehicles, they have a central unit using which you can pretty much operate your complete car. And going forward, what we can see is the car with no steering and nothing. So it will be complete autonomous vehicle. So using a dashboard, you will just tell the car where to go, what to do, and that's it. So basically your car will be completely controlled by that central computer. We call that a HPC, high performance computer unit. And basically there are going to be other issues as well regarding other functionality, and all these domains will be connected to this central computer, and this central computer will be connected to your cloud or other V2X features. And going forward, this V2X part is we can see it is evolving, and it is also introducing new vulnerabilities. This all E2E network, which we are saying that okay, this is a very cool and hip thing, but this thing is not cheap. It is adding some complexity in from technology point of view, from cost point of view, and all. And these are creating some challenges for the OEMs. So these challenges are mainly time to market for new features is low. Communication bandwidth required to achieve this new functionality is less. So these functions need more bandwidth, but we don't have that in our current systems. And V2X communication capabilities are required, as we have discussed. OEM needs to differentiate their product stack. So, for example, if an OEM launching two cars, then they want those two cars to be some different things. They want them to uh, provide you different feel, same as with the different OEMs. So a car from two OEMs should not feel same. They should feel different, despite they are using the same components at the core. So this is one major challenge faced by the OEMs. And the second thing is the this all technology is not cheap. This R&D and production costs more than the usual mechanical components, but customers don't want to pay more for their cars. So OEMs need some revenue model so that they can charge less upfront but recover their costs over the lifetime of the vehicle. So identification of these new revenue streams from the OEM's point of view is also a crucial thing. So what AUTOSAR's take on this all problems and this all future thing? So AUTOSAR has defined certain goals for themselves and certain goals for the networks or OEMs. These mainly use Ethernet as a backbone of your network, connect everything through Ethernet switch. All hardwares will be connected to each other using Ethernet switch, which will mostly reduce the wiring harness cost. So currently all the components are connected to each other using separate wires. Those wires, their specifications also differ from component to component. So this all creates a big chunky wiring harness in a way inside a vehicle. But that needs to be gone because it includes a lot of complexity. It also includes a lot of point of failure. So if everything is switched to Ethernet and everything is connected to using Ethernet switch, then we are reducing the cost and we are reducing points of failure. Then there is something called hardware as a resource. So what does it means is basically if we have a camera, let's say we have a front facing camera, then we want to use that same camera for ADAS functionality, and we want to use that same camera for as a dash cam, which will record our all journeys. So we want to use same hardware for multiple functionality, and how it can be achieved is using providing hardware as services and not just like a physical connected sensor. So this goes on with all the things. So the 360 cameras can be also used for ADAS functionality and then getting some blind spot assist during turning and such things. And the last but not least is providing updates through OTA. like over-the-air updates, same as your mobile phones. So these are certain goals which are set by AUTOSAR consortium, and there are certain standards which needs to be described to use those. And no one wants to reinvent the wheel from the scratch. So AUTOSAR consortium has a classic platform which is tried and tested model which is there, and in other domains there are some tried and tested technologies like ROS, Linux, Android. So these are again tried and tested technologies, but they are not as suitable in automotive domain. So classic platform is more resource constrained, and it is not suitable to provide these high-end features as well. So what AUTOSAR consortium did is they combined best of both worlds and created adaptive platform. So now adaptive platform supports both classical platform, and it has lot of this standard which are already present in other domains into it. So now it is high, it has high computing power and relatively safe as compared to other standards. So it's best of both worlds, and it is fully compatible with classical AUTOSAR platform by default. So when we say that they are fundamentally different, like classical and adaptive platform are fundamentally different. So what does we mean? So basically, classical platform is based on or more efficient on microcontrollers. It is fail operational state. It provides fail operational state. So that means it's SLD compatible. It works on OSIC based OS. It has a fixed task configuration, and the communication mainly works over signals. Whereas in adaptive platform, it is based on high performance computers. So basically something like SoCs in our phones, which has a dedicated hardware functionality for certain features. It provides obviously OTA. It uses POSIX based OS. It is fail safe, not fail operational. So we can achieve till SLB level safety with this. Everything is service oriented. All the communications are service oriented, and it supports a dynamic scheduling to achieve the dynamic behavior depending on the scenario. And how adaptive AUTOSAR is achieving these goals. So the software is divided into three blocks, three functional clusters. First, platform cluster, uh, platform foundation cluster. Second is platform services cluster, and third is service or application cluster. So platform foundation cluster includes functionality like operating system, uh, diagnostics, communication, or synchronization, cryptography, this core functionality. The uh, platform services cluster has additional functionality which is required as maybe update and configuration management, network management, diagnostics, state management, these kind of services. And the third is service sector, which includes all the application and some OEM specific services. And this all complete software stack runs on can run on anything. So basically it can run on virtual machine, it can run on in containers, it can run on bare bone hardware. And each block contains, or when we say application, then it contains three things. First is a POSIX executable. Second is something called as execution manifest, which provides information how to run this software. And the third is service instance manifest, which provides the communication related information. And development flow of this is like A and B, which is platform definition and platform configuration. It will be provided by OEM to their vendors. Vendor then can use this and develop their own application application software package, which is C. which will contain all these three things: executable, execution manifest, and service instance manifest. And all such packages will then be deployed onto your ECU, your hardware, in through some background server. So there are lot of there is a process which is idealized for this, and this process is, let's say, there is one vehicle which has some version of software into it, and some vendors like integrators like A and B, they have created new applications and they have pushed their applications to software catalog, which is present at cloud, and OEM authorized that okay, this is correct version, these are validated features, and they can be pushed to the vehicle. So at that time, what will happen is vehicle will say, hey, this is my software version. Whenever it gets connected to the cloud, cloud will then identify whether new version is required or not based on the database. And if it is required, then it will perform the authentication using vehicle serial number, and again some public keys, private keys, and all those things. Authentication will be done using those things. Once authentication is done, the vehicle package will be provided to the vehicle, which is then supposed to be updated and activated inside the vehicle. Once this software package is activated, vehicle will notify to the server that okay, my software package has been activated and this is my new software version. This information will again be saved at the database, so it will be available to OEMs for diagnostic purposes. Like something happened, let's say some error is faced by the customer, then OEM will get to know that okay, what is the software version, what might be the issue, and what to do, how to provide a best service to the customer, and maybe they don't have to come back to the service center to get it serviced. So this is all cloud-based update and configuration or software development and delivery mechanisms. And there is a sorry. Yeah. This all package development goes separately because there is not a hard dependency between two softwares in adaptive platform. So let's say vendor A and vendor B can work independently, can develop their softwares in parallel, which will be then collected by the central vendor, which is basically OEM's cloud management vendor. He will collect all those softwares. He will provide them a lot of security part using authentication tags. There again, lot of cyber security related stuff happens over here, and then this will be provided to the integrator's repository. It will be saved in the integrator's repository, which we just saw in the previous previous flow. And this individual software package looks something like shown in the image. It will have basically these three parts: executable, data, and manifests. Then there will be a lot of authentication tags, software package manifest, and other supporting metadata. And all such individual software packages together will consist of a vehicle package. So we are saying that service-oriented communication is the key in adaptive AUTOSAR. So what basically it means? So basically, service-oriented communication means it is a design pattern which has three main players. First is service provider, which has actual some data to be provided. It is basically a service generator. Then there is something consumer, service consumer. It is something similar to IVI system, and service uh, provider in that case can be a camera. So service user will first check with the service registry. So service registry is basically something like a registry where all the providers will be listed with their services and their IDs, and service user can check in the registry and identify which service needs to be used from which provider, and then service user can make a connection with the provider, and then data exchange can happen. So these service users and service consumers can be distributed in any scope. They can reside in same process. They can reside on two different processes, or they can reside on two different machines by themselves. And this all communication from application point of view or is same. They don't care whether the other party is. And this mechanism is provided using Eracom middleware. So Eracom middleware isolates the actual uh, implementation of communication from the uh, applications. So Eracom in itself has two layers. First is a language binding layer, which uses proxy and skeleton interfaces to provide this virtual network or virtual communication bus between application. And then there is a communication binding, which actually translates this to the actual communication protocol. So, for example, let's say if we are saying that two applications are communicating which are residing in the same process, then maybe shared memory will be used. If they are in two different process, then IPC, POSIX IPC needs to be used. If they are on two other machines, then we need to use some protocol which works on Ethernet, something like SUM IP or DDS, or some other mechanism, some proprietary mechanism which works on Ethernet. So these things needs to be used, and Eracom communication binding provides this capability. So this is a small example where we are seeing that there is communication. There are four services, like service A, B, C, and D, and there are multiple instances of those services. Some are senders, some are providers, uh, and these are all are distributed across four issues. So we can see there, out of which two are adaptive platform, and please note that the two are classical platform issues, because classical platform also supports service oriented architecture over some IP. So these providers and senders are distributed between applications. It can also be part of platform cluster or uh, some BSW service of adaptive platform. This can also be accessible to classical platform using Eracom middleware layer. And classical platform currently only supports some IP based communication. So all communication which happens with classical platform uh, by any other adaptive platform has to happen through some IP. But in between communication in between adaptive platforms can happen through some other protocols as well, like DDS, or uh, there are some proprietary protocols as well, or communication between adaptive platform and X, like maybe IoT device, or maybe your traffic system. So that can happen over DDS or some other REST based services are also supported to directly communicate with cloud. So these all type of actual communication protocols will be provided through Eracom, but from application point of view, it's just a service. It can reside anywhere, and application don't care where it is, because it is always accessible to the application. Okay. In adaptive platform, there are basically something called as proxy classes, which are used by the generator and service provider. There is something called as skeleton classes, which are used by the implementer, service provider. Sorry, my mistake. The proxy classes are used by service consumer, and skeleton classes are used by service implementer, that is service provider. In these services, there are basically three types of services. event-based service, method-based service, and field-based service. So event-based service is a bidirectional communication, and it is like some service request which is happening from service consumer side to service provider side. Uh, in event-based communication, it is also bidirectional communication, but it is from provider side to the consumer side. So it generally it is used for data communication, and methods are used for some service requests. Let's say for reverse parking service, so activate the camera, or change camera mode, or activate the indicators, or change some driving mode of the vehicle. So such type of services are generally method calls. And constant data communication, that means actual feed from the camera, or let's say actual vehicle speed which is required by the dashboard, which will be provided by the odometer, sorry, not odometer, but speed sensors. Then there will be odometer readings. So all these are constant information. So they are generated by one device using some sensors or whatnot, and they are required by some other party to perform their work on it. So for example, IVA system needs all this information to display, or uh, airbag ECU needs the information from the sensor to detect whether to deploy airbags or not. So such type of things. So they will mostly use events, and then there is something called as fields. So fields are a combination of methods and events. It is bidirectional. So it will be some service request, and based on that request, there can be some data which is to be provided to process the service, or some data is expected in return from the service. So this will be facilitated by the fields. So there is a relation between adaptive and classical platform. So adaptive platform, when we say events, they can be related with the classical platform sender receiver interfaces, basically data communication. Then fields. So now fields have sorry, not fields, methods have 2 3 types in between them. So one is fire and forget method with parameters, fire and forget method without parameters. So if we are saying methods, so purely methods are uh, related to client server interface in classical world. And if we say fire and forget method with parameters, it is again just a data communication where the uh, consumer is not expecting any acknowledgement from the provider. It is just sending, okay, this is some data or this is some operation, work on it. So this is fire and forget method without parameters, sorry, with parameters. So it is similar to sender receiver interface. Then fire and forget method with parameters is similar to the trigger interface in classical world. So it needs some data to work, and it needs its interrupt kind of behavior. So basically a trigger. Then there is fields. So fields is a combination of both client server interface and sender receiver interface. There the operation will be invoked using client server interface, and sender receiver interface will be used to exchange the data, and it works both ways. So let's have a short overview on how these things, how the service communication works in classical world. So in classical world, this is divided into two implementation paths. First path is service discovery. It uses BSWM's mode request and mode switch port interfaces. And the second path is communication path. It uses COM and again communication stack. So as we can see over here, this service discovery and communication, there is capability in the BSW, but there has to be an application which is performing these operations. So if we say in case of service discovery, there has to be application software component which is triggering this discovery, which is keeping the table service registry, or when to update the service registry. So there should be application which is brains over this actual communication, raw, low level communication. And in communication path also, there has to be application which is providing this client or server interfaces, or which are used by methods. There has to be application which is providing sender receiver interfaces, which is supposed to be used by uh, for events or for fields based communication. Then AUTOSAR's COM module in classic platform will connect with this application interfaces, and then route this data using PDUs through PDUR to our Ethernet stack, basically a socket adapter, and from there it will using actual communication binding, TCP, UDP, or what communication protocol, which IP stack needs to be used. So all these decisions will be taken care of during configuration of ECU, and it will go through this communication stack through Ethernet. So one point which I forgot to mention, or to clarify, is that when we say in adaptive AUTOSAR, so adaptive AUTOSAR, everything is dynamic. So whenever some software update happens, so it uses it loads into the execution state at runtime. So system don't have to reboot, or system don't have to go offline to get these updates. And individual part of the system can also be updated. So for example, if we have some vehicle running with some software version, and one small part of that software is updated. So for example, let's say we have a car with a reverse parking sensor, and the reverse parking assist functionality is updated. So only that part of software will be updated when other part of software is running. So it's same as some application in our mobile phones or in our laptops. So all the software components are like small applications which are running on POSIX OS. So they can individually be updated. What does it means is we can add new services, or we can remove few services from adaptive platform, but this is not possible in classical world. This is not possible in classical platform. If you want to update the classical platforms issue to support some functionality or some behavior. Sorry, this was not a right slide. Yeah. So if you want to update or add new functionality to classical platform, we have to first configure it. We have to generate a new binary for complete software, considering all application and all BSW modules, and then we have to update the complete software. Some part can be used using variants, but mostly we have to update complete software. But in adaptive, we can just update one application, and we are good to go. So this is some constraints when we use classical platform in the mix in the network. So that's why we want to reduce the use of classical platform and consolidate all the major applications on single platform. And then it doesn't mean that classical platform is going to be phased out or it is not going to be used. It will be there, but its role will be different. Its role will be to operate individual issues, safety critical issues, and not provide high level functionality. Currently, a lot of classical platform are used to provide some high level functionality. So for example, ADAS functionality currently mostly works on classical platform, or advanced functionalities such as like remote key access, or the vehicle senses your sitting position and adjusts all the parameter according to it. So all these comfort features are also currently working on this classical platform, but they needs frequent updates, and they needs frequent bug fixes, because uh, currently to tune the features we need to tune the some configuration parameters, and those parameters or those tuning might add a few bugs. So it needs constant updates, such functionality. And currently using classical platform, as we have to update the complete software, the customer has to come to service center and has to wait for some time. Whereas when if we are using adaptive platform, then everything will can be done from his garage or while on the road. So basically, it will increase the convenience of both OEMs and consumers. So consumers will get better services, and OEMs will reduce their expenses while providing the better services. So it's a win-win situation, and we hope that in future what we can see is all these vehicles are going to be very, very nice. And mostly we are moving toward, anyways we are moving towards driverless cars, so they need a lot of computational power and lot of functionality. And if we are not driving, then the person needs comfort because otherwise he will not use the vehicle. So this was a very short overview. There are a lot of things to be discussed in, and there are a lot of complexities, lot of technologies involved, which in itself are very huge, very vast, very complex. So I see that uh, this overview would be helpful to get you just started in this field, and it will mostly interest you to explore this field on your own. And we hope that you will enjoy while working with Adaptive AUTOSAR. So that was all from my side. Now we can discuss some questions if we have. Okay, thank you. Good evening again. Have a good day, everyone. And thank you for attending this webinar. See you soon.